Okay, we were talking about search space, and we were saying that if you construct a nice architectural search space, this will help the next step, which is the search strategy. So in your search space, you find an architecture which will create with different parameters when you provide. So think of this as a function. You provide some parameters, it creates an architecture. So search strategy will change the parameters, and each time search space will give you a new architecture. You'll change the estimation, you'll make the estimation and find the perfect one. So how do you feed these parameters depends on the structural elements of this search space. So let's get an example. So for example, think of a module in which the general structure is fixed. You have cells you have 5 inception-like modules. You have 3 in this case. We have the input, we have the output. We have 3 modules. We keep this fixed, but we only change the inside of it. So what you're saying is, in my search space, I'm going to always provide an architecture which will get an input and provide an output, which has 3 blocks, and each block I'm going to call these blocks as modules or cells, and I'm going to use these block, module, cell words interchangeably these terms. But we're going to change these. So we are seeking for an inception-like module, in which this inception-like module is used serially in 3 layers. So what you do is, you are looking for a micro-cell information. This type of search is known as the micro-search or cell search. And this is very common. Constructing these kind of search spaces is very common. So either you find this, or you just change this. You change all of them together, or you change only one of them, and you search for different cells. The general architecture is not changing, but you're changing the inside of the cells, and you're looking for modules, inception-like modules, the perfect one. The architecture, the strategy is searching for it. So you structure your search space, and the search strategy finds the perfect one by testing them and training them each time. So don't make any mistakes. So each time a search strategy provides an architecture A, the search space, the search strategy selects an architecture A. What it does is, it calculates the estimation, estimates the performance, calculates the performance of it. How it does it? It just train it from scratch. So each time, at this iteration, you train a network. So it's a very heavy operation, guys. At each iteration, you are doing the total training. That training has many iterations. So iterations of iterations. You are doing tens of thousands of training. And you're looking for the best strategy. We'll discuss these when we come to performance estimation and search strategy. Anyway, so you can structure your search space just like this. So in many actually methods in the literature, these micro and macro structures are searched in a hierarchical fashion. Hierarchical means you start with a lower hierarchy, a simple cell. You make the cell more complex and more complex and more complex. So these consist of several levels of motifs. These changes in these blocks are called like motifs, guys. For example, these contain some primitive operations. At the first level, different motifs that connect primitive operations. We have directed acyclic graphs, just like in these. The third level motifs encode how to connect second level motifs. So first you find inside of these. Then you decide how to connect these guys. So you structure your search space in these are called motifs. Little changes are called motifs. This is how you structure your search space. How well you structure, how well you handcraft your search space, the structure of your search space will designate how well you do your search strategy, guys. It's a very important thing, the search space. And the search spaces are designed in a very hierarchical and continuous chain-like manner. Okay, and finally about search space. There's a nice paper, a guy called Zoff, one of the authors, the first author, 2 years ago. What they do is they construct a structure in which they have 2 types of cells. A normal cell, which is normal convolutional layer, but it's a convolutional module. The other one is the reduction cell, just like a max pooling layer. But Max pooling layer is very simple. It's just max pools. It's a combination of layers. So it is doing some operations when it's reducing the function. So it's trying to find what the normal cell will be like, what the reduction cell will be like, and by combining these two instances of these normals and reduction cells, they find an architecture. So the final architecture is then built by stacking these cells, normal cells and reduction cells, in a predefined manner. The overall architecture is set. It is like saying, I have a normal cell, then a reduction cell, then a normal cell. It searches for these guys. So it's a very nice handcraft. So in figure 3, actually, it is one of the implementations of these. This is how you handcraft your search space, guys. Okay, so the search space has 3 major advantages compared to ones discussed above. This kind of search space, having normal or reduced cells. The size of search space is drastically reduced because you know what to do. You are handcrafting your design. And when you just confine it, the search strategy will converge much easily. But the downside of it is, we've discussed this, you will be adding a human bias. You don't know if it is good or not. But Zoff et al. With this architectural design, this hierarchical normal cell, reduction cell design, they have achieved many good results, guys, from the previous works and their works and the other works. So this is one of the current nature of the search spaces, guys. Still, we are trying to handcraft these guys, because this is the part we are handcrafting here. The other parts are more like optimization procedures. There's not much handcrafting you do. You do handcrafting. We are going to discuss these, but this part is the hardest handcrafting we do. So we have carried our handcrafting from pattern recognition to deep learning. Now we are carrying our handcrafting from designing deep learning layers to designing our search space structures. Very good. I think we now have an idea of search space. And this slide says that architectures built from cells can more easily be transferred, adapted to different data sets, because you are finding some structured cells. You can carry them. You can carry them with their weights because they are automatic feature creators. And what they do is these guys in their paper, they train it in a set, and they carry their trained modules to another data set and show that it's working. So with this architecture, your modules and the weights in your modules become transferable as well. That's a good idea. It's just saying that it's a good idea. Okay, how are we going to do it in the second part? This slide is saying that transferability to other training sets will also work on recurrent neural networks as well. So it's a bit beyond the scope of this week's title, so I'm going to pass it a bit quick. So what is the next step? The next step is search strategy. Before we come to search strategy, final words on search space. It's a difficult job. When you do many cell architecture, many design choices will arise. How many cells shall be used? What is the general structure? You don't know. So adding human bias will just take something from you. So in many methods, actually both microsearch, the cell inside, and the microsearch and the macro search, or the architecture, general architecture, they are both searched, which increases the difficulty of the search strategy. But it's done in a hierarchical fashion. The first find the inner cells, then you make the architecture bigger and blah blah. So you do it this way, and if you just continue on this field, please know that this handcrafted search space is one of the state-of-the-art businesses that people throughout and researchers throughout the world are working on. So just keep that in mind, guys. The next title, search strategy. Let's continue this on the next video.